Evening, everyone. We are going to start within 2 to 3 minutes. Let others also join. Then we will start with the presentation session. Good evening, everyone. I hope that all of you have covered your this week project. So let's one by one present your week 3 project. And those students who have not presented their previous week project, they have to present that also. Okay, so I have the list with me regarding the previous projects also. So, okay, let's start with you, Aditi, first of all. So just share your screen, let us know that what topic you have opted for, and then go with your presentation.
Yes, sir. Just a sec. Shall I go with the week 2 project first or the week 3?
Okay, so just share your screen first and then let me know.
Then I'll go with week 2 one. Okay, so this is the cryptocurrency price volatility analysis. So this is for the week 2 project performing
Uh, I guess your voice is breaking a bit.
on the data set.
Hello, Aditi.
So I've used Bitcoin, Ethereum, and Litecoin for the analysis.
Sorry, I think your voice is breaking a bit. Can you please check your internet connection once?
Yeah, I am checking it. Is it audible now?
Yeah, now it is a bit clear.
Um, okay, thank you. Okay. Is my screen visible to you?
Yeah, now you are audible and your screen is also visible. I am able to see install and import libraries. That slide I am able to see.
Okay. Okay, so I'll start with the presentation itself. So my week two project was based on cryptocurrency price volatility analysis. So for the analysis of the cryptocurrency, I have used the three major Bitcoins used widely, that is Bitcoin, Ethereum, and Litecoin. So
Okay.
I have fetched it live from CoinGecko public APIs. So here I have installed the major libraries that are important, and these are the libraries that I have used: Pandas, NumPy, Seaborn, and all the others that are needed.
Okay.
And this is basically the fetching of coins from the APIs itself. So Bitcoin, I have used 366 rows, and Ethereum 366 rows, Litecoin 366 rows. The combined data set includes 1098 to 5. And it's basically of 1 year trends. So yeah, this is the preview
Okay.
of the first few rows. And talking about what each row represents is the date, symbol, price, volume, market cap, market cap. So the total market value of the cryptocurrency. Volume denotes the average trading. Price is the price for the closing price of the cryptocurrency for that day. Symbol is BTC, Ethereum, and LTC for Bitcoin, Ethereum, and Litecoin, respectively.
Okay.
Here is the dataset overview. Like as I said, date, it's the date time type. Price, market cap, volume is the float type. Symbol is an object type. And this is the descriptive analysis that I have 1098 entries of price, this entries of volume, and this entries of cap. The mean of price is this, and so are the other measures.
Okay.
So price statistics per coin, that is, it is in USD because obviously the Bitcoins are traded in the US dollars. So the count of BTC, Ethereum, and LTC is 366 rows, as I mentioned beforehand. Bitcoin mean is significantly larger than all the others, and the standard deviation, minimum, etc., all goes on so on. Now from here, we will be doing data pre-processing and feature engineering. So for the first, I have done the missing value analysis, but there were no missing values since I used the dataset from the API itself. So there was nothing to be cleaned. Then I have
Okay.
extracted features like date, and then temporal features like year, month name, week, day of week from the date itself so that I could use it to analyze monthly and yearly trends. And now in this one, I have added daily return feature and simply daily return in percentage. And this is the first few entries of it. So you could see the daily return of each Bitcoin is like very, very varied. So we'll go on to rolling averages, starting the moving averages. 7-day MA is the 7-day moving average, 30-day MA is the 30-day moving average, 90-day MA is the 90-day moving averages. And
Okay.
these feature extractions, nothing more than that. Now we'll go on to do the EDA. So the first trend that you would see here is the daily price trends of Bitcoin, Ethereum, and then Litecoin. You could see that Litecoin has significantly lower price than Ethereum, and Ethereum has significantly lower price than Bitcoin. So Bitcoin trends goes on for like millions of dollars, whereas the other two doesn't run that far. And then this is the normal price comparison between all the three, which is rebased to the 100 so that I could compare all of them. So even though Bitcoin is traded on the more price range, Ethereum is still more stable than you could see in the normalized price comparison.
Okay.
So this is the rolling average trends of each of them. So the green line denotes the 90-day moving averages, and the lighter one, skin colored, is BTC price. And the blue one is the 7-day moving average, and the orange one denotes the 30-day moving averages. You could see that it goes on like this. That means the 90-day trend of this is gone significantly lower. That means in the 1 year, it has gone down a bit.
Okay.
This is the 30-day moving averages of all the coins. This is the Bitcoin ones and Ethereum and then Litecoin. Now we'll go on to do the volume analysis. This is the daily trading volume of all the coins. You could see that some days it has a higher peaks. This would be because of the news or market values, if there's any new rules or any new thing that would come up. So volume tradings has gone significantly up, and this has been same in all of them. So whenever the price goes up in BTC, it goes up in Ethereum, and it goes in Litecoin itself. So you could say that all of them are comparatively like correlated.
Okay, good.
Now we do go on to the price versus the volume. So you could see here the volume goes up, so the price goes up too. So when there's when the trading value goes up, the closing price volume goes significantly high.
Okay.
And this is the daily returns. Green one shows the positive returns, red one shows the negative ones, and it goes on to show the daily returns from 1 year. So yeah, this is it. Nothing more about it.
Okay.
Now we'd go on to do the distribution of daily returns. This is just the normal distribution about this. And honestly, if you consider 1 year as a trend, there's just the normal distribution. There's no significantly high returns or the low returns. It's almost similar. This
Okay.
is the case return, which shows that Bitcoin has a higher peak than both of them, and LTC has more risks because it's spread like this. So yeah, if you would invest in LTC, you would be going for a significantly higher risk. This is just a 30-day rolling volatility. So yeah, you could see that these three go all the same in trend. So when volatility of Bitcoin increases, all the three increases accordingly. And this is just a 7-day rolling volatility. It almost shows the same, but I would prefer using 30-day rolling volatility for analysis itself.
Mm.
And this is the heat map. The dark red shows that volatility increased significantly. So yeah, for the Bitcoin, February was the month where people has seen the high volatility, but it could be different for the Litecoin itself. This is the correlation matrix. For price, you could see that there is high correlation between the prices. It is because of the market. Because as the market goes up, all things goes up, and as the market goes down, all things goes down. So therefore, this is the highly correlated to each other.
Yes.
And for the daily returns, it's a little lower, but almost same. So here is the scatter plot of daily returns correlation. So this shows if the scatter plots is closed, then BTC and Ethereum are highly correlated. So if this is somewhere different from this, so that means there's a huge error between both of them. That means Ethereum and Bitcoin in this phase was independent of each other. So as close
Uh,
they are, it's more dependent. And this is the pair plot for daily returns of all the three coins. It basically shows a correlation of all of them, nothing more.
okay.
And this is the box plot of monthly daily return distribution. So you could see I have used the color coded for all the months. And this baseline is just a baseline for when the high goes high and you get the profit or the losses. So if it's more than that, you go for profit. If it's less than that, you go for loss. And this is just a violin plot for all of them. It doesn't show much differences. It's similar to the box plot, but just in violin shape. And this is market capitalization over time. You could see that Bitcoin has been racing really over than Ethereum and Litecoin. Litecoin is so significantly lower than both of them that it shows at $0 billion, but it's not. It's just that it's so less than both of them that it's not even able to show up in this graph.
Okay.
And this is the market cap share. You could see that Bitcoin just goes on and on market. People trade more on Bitcoin and less on Ethereum and Litecoin. And this is the cumulative return for all coins from the day one. So just think if you invested $100 here, you would be at 200 times gains. So that would be like $20,000 and you'd have for $100. So it's crazy, right? And here, if you go for an year trend, it's significantly lower. You'll only have 50% rise in your market. But if you would have invested in Ethereum, then you would be in profit. But Bitcoin and Litecoin has shown the loss. Yeah. So this is just the price, volume, and 30-day moving averages of all of it. This line shows the moving average. This is the Bitcoin price, and this is the volume traded. So this is all three in just one chart.
Okay.
And this is bull versus bear phase rejection. Bull and bear phase rejection is just the 7-day moving averages is more than 30-day moving average. That would be bull day. And if it's less, then it would be bear detection. So the green one shows the bull phase and red one shows the bear phase. Green one shows where you've made your profits. Red one shows where it's the market is going down a bit.
Okay.
And this is 30-day rolling volatility comparison of all the three. I mentioned this before too. I'm mentioning it again just to show it. And this is the price drawdown from all-time high. So if this just shows that throughout the 1 year, the price drawdown is significantly high. It's really a lot.
Okay.
And this
Okay.
is average daily return by day of week. Saturday, Sunday shows the loss because market is usually closed during those times. So people usually take out their money from the Bitcoin itself. Hence, it shows the red thing, and it's traded more on the weekdays. So yeah, it's green. But for Litecoin's almost opposite because people don't trade more on it. So yeah,
Yes.
this just shows the final insights of what I have done in this whole year. We have done risk profile, we have done the correlation, we have seen the trend observations, we have done volume insights, basic risk insights, and seasonality. And coming on to the final summary table, this is average daily return. So I wouldn't suggest investing on Bitcoin. Yeah. Yeah, that is it about the week two project. Thank you.
Okay, okay. Great work, Aditi. Also, the project is well explained by you. So great work. So this was the week two project, right?
Yes.
Okay, so have you completed the week three one also?
Yes, I have. I'll show it. Yeah.
Okay, okay.
So this is the week three project. I have done customer segmentation for a retail store, and it has like 99,457 records. I've used tools like Python, Pandas, like Scikit-learn, Matplotlib, Seaborn, Plotly, etc. So these are the core libraries that I've used, and this is the data set, which has customer ID, gender, age, payment method. And this is the data info. So the customer ID is object type, gender is object type, age is float type, payment method is object type. And these are the first few, descriptive stats. Coming on to the data pre-processing, I'm checking if I have any missing values. Then I had 119 missing values, which just comprises 0.12%. So I have just moved and dropped those sets instead of changing it. So after dropping it, the data set includes 99,338. And then we'll do the encoding of categoricals. So the female was encoded to 0 and the male was encoded to 1 because they were object type. So I had to turn it into the numerical ones. And cash
Okay.
was credit card was encoded to 1, debit card was encoded to 2. We're checking if there are any outliers on age, but there were no outliers detected. So yeah, there was nothing to do on that. We'll do the feature scaling now. And this is the scaled feature statistics. So yeah, we'll go on to do the ED on it. This is the univariate analysis. So we are just looking for one variable as of now. Age distribution, you could see it's almost similar, but KD plot is very well distributed. It just shows how the age goes. It's almost similar. So yeah, you can't distribute the data between the ages to get more analysis. This is just a gender distribution. So females usually buy more from malls than males. This is the payment method distribution. 44,000 people use cash and the rest use debit cards or credit cards. So if you would add it to almost 56% use go cashless, whereas still 44% people use cash. Yeah,
Okay.
45. And this is bivariate analysis. We would be considering two at a time. So age distribution by gender, it's almost similar, but female are more than male. And this is just a box plot to show the same. There are no outliers here. And this is age versus payment method. and it almost shows that all the three use all of them. So yeah,
Okay.
this is gender versus payment method. The blue one shows female and pink one shows male. So yeah, female almost there's more than male, and they almost use all of them. So you can't just decide if you are going cashless, so it could be a female or male. This is age groups versus payment preferences. It just shows that 18 to 25, there are 15,000 customers between them, and 19,000 between 26 to 35, 19,000 between 36 to 45, and 26,000 between 56 to 69. Okay, so old age people use go for more offline shoppings. Yeah,
Okay.
this is just the same thing but in percentage. And this is violin and strip plots for age versus payment. So you could say it goes like this. There is no clustering. It's all linear and normal distribution. People go for this. And this is
Okay.
feature relations. This is like they aren't identity related to each other. So you can't decide about age and gender based on the payment methods. And this is age CDF and age group and gender. So you could see that this is a slope, and in 43 crosses the mean. So that means 43 age is the mean of people that goes on buying, and this is the age group and their count. Now we'll go on to perform the feature engineering. So we have features used, that is age, gender, payment, is senior, is young, and is cashless. So we have computed the inertias and silhouettes, and we have used the elbow method. So this is where we would use our K because it gives the best selection. So the optimal selection would be K is to 4, and this is the silhouette score for K.
Okay.
And then we'll go for cluster evaluation and profiling. This is just count average age for how many clusters and what percentage of female and percentage in cash, credit, debit, cashless, senior and young. So yeah, so the zero cluster shows the traditional shoppers. First one shows the digital spenders, second one shows senior cash buyers, and the third shows the young cashless adopters. For the cluster visualizations, you could see PC total is 71.04% is the CPCA. And this shows the cluster visualization of it. So this is K means cluster and age distribution by clusters. You could see that 20 to 30 are the traditional shoppers, whereas young cashless adopters are this much. This is the density. And senior cash buyers is this, and this is the digital spenders. That means they go cashless.
Okay.
This is cluster composition. That means 24,900 something is traditional shoppers, 20,900 is digital spenders, 20,000 is either by cashes, but these are almost similar, and 33,000 are young cashless adopters. So payment method mixed per cluster. This is just in percentage. This was in numbers. This is cluster demographics, gender mix plus class per cluster in percentage. So you could see traditional shoppers had 60% females and 40% males, and this is almost similar in all of them. This is the 3D PCA cluster visualization, whereas the blue one, you could see that this is color 2 and this is color 1. Means the cluster 0, 1, 2, 3, which I mentioned earlier. This is the color 3 and this is color 4. I guess, yes, color 0.
Okay. Okay. Good.
And this is the radar chart. This shows almost similar thing. I've just used charts to see what shows the better results. Yeah. And this is
Okay.
Sunburn plus Tilda payment. So if you want to see how many cash were made by females of young cashless adopters, there were 19,867 and similar for all the others. So you could see the count here by itself.
Oh, yes.
So this was it about the all the clusters, right? And this was the final segment summary table. So if you would see for traditional shoppers, it was 25,000 and average age was 24, whereas percentage females was 59.6 and their top payment is cash. They go 55.3% cashless. So if you want to see how many people go cashless, it was more about digital spenders and senior cash buyers. They don't you prefer cash, they prefer credit card or debit cards, whereas young cashless adopters go for cash. Yeah, so that is it about this.
Okay. So first of all, very well explained, Aditi. Both the projects were really good. So great work at your end. Just I want to ask that have you shared your calibration report? Because I don't think you have shared that. So if you are facing any problem in that, then just let me know. I will try to resolve that. Otherwise, you have to share that to me by today's end of day. Okay.
I'm sorry, I wasn't told that I had to share the calibration report.
Okay, okay. So basically you have to share the calibration report also for week 2 as well as for week 3.
Okay, okay. So what do I have
Okay.
to do in that?
Uh, okay. So basically, let's just give a second. Let me. I will just explain it after taking one to presentation. Up to that, I will just check the file because a project calibration report has been shared to the group in which you are joined. And in that, you have to mention the details of the project, like whatever project you are completing, you have to fill out the details regarding that project, that what is the project topic, from where you have take the data set and other things. So I will let you know once I will take one to more presentation. Okay.
Okay, okay. Thank you.
Okay. So now, Pranav, have you completed your project?
Yes, sir. Yes, sir.
Okay, Pranav. So just share your screen and let us know that what you have created and just go with the presentation. Yes, Pranav, your screen is visible.
So my project is on Western music listener by preference. So the goal of this project is to predict the popularity of songs by using the audio features such as energy, loudness, and etc.
Okay.
And also to find the identify patterns and find the trends. So first I have imported the libraries, basic libraries, pandas, numpy, matplotlib, seaborn, uh, and other ML libraries, and also the PCA. Then after that I have loaded the dataset. After loading the dataset, I have printed the first 5 rows of the dataset, which include track ID, artist name, album name, and track name, and all of these. Next, I have this shows that how many rows and columns are in the dataset. It shows that there are around 1,14,000 rows and 22 columns. This is DF of clean info. It tells about all the information about the dataset, whether it is null, non-null, its type. Next to the
Okay.
column is data type. It tells us about all the columns in the data and what is the type of that data. Next, we will see duplicate values. So in duplicate value, first we will see are there any duplicate rows. Then we will see the duplicate columns. So we can see that there are no duplicate rows and columns. But if we see that there are if we check a column or duplicate, we can see that these are the other duplicates in the data sets. So after there are unique values, then we can see that these are all the unique values in the data set. Then
Okay.
data statistical summary. It tells all about the data set, like the that the popularity of a particular song is around 33%, like this. Now, after this, we have the missing values. So we can see that there are only three missing values, not much that much missing values. And if we try to visualize the missing values, we can only see a blank page, but because the data set is so large, it cannot find the missing values. But we can see by this graph that there are only three missing values with the name of artist, album name, and track name.
Okay.
So after that, we will do the data wrangling part. So firstly, I have removed the duplicates based on the track. Remove the duplicates, then we will be removing the duplicates, and after that, I have the final shape of the data set will be around 70,000 after removing the track ID duplicates. Next, I have dropped the irrelevant columns in the data set and also handled the missing values. Next is the IDA. So first is the popularity distribution of the songs. We can between 1 to 100 and 200 we can see that particular song is like is speaking at around 22. So it indicates that a particular average song is popular around 20 to 22 people in between 100.
Okay.
So next is the top 10 artists according to their number of songs. So these are all the top 10 artists by the number of their songs. Next is the explicit versus non-explicit. It tells whether the songs have any. So explicit songs are those types of songs which are having are having any bad words, and which is adult. Basically, adult songs are called explicit songs. So we can see that there are very less explicit less
Okay.
explicit songs.
Okay. Okay. Good.
And after that, we have the danceability and the popularity. So there is no strong pattern in between them because uh, it does not guarantee whether the particular song is popular or not. Next is the energy distribution. So we can see that the graph is slowly higher. Next is the correlation heat map. Uh, most features have the weak correlation between them. So this suggests that the model has performed low. Then there is the top 10 genres that has been listened. Uh, so we can see that black metal, comedy, and Afrobeat are the among the top three genres that have been listened. And next is the loudness and versus energy. So we can see that if we are increasing the loudness, energy is also increasing.
Okay.
So next is the tempo distribution. So we can see that the tempo distribution is between is higher between 120 to 130, which means that the tempo is increased. Next is the box plot for the outliers. So we
Okay.
can see these are the outliers of this data set. After this, we have the PCA. So I have applied PCA to reduce the dimensionality. Uh, I have selected the numerical columns. Then after we perform the scaling, then I have applied the PCA. Then I have identified the rows with the NaN values and filtered out those which have the NaN values. And I have created the data set of between PC1 and PC2, and also find its variance ratio. So after that we have the PCI visualization. So we can see there are no clear clusters found. So the final, so we so it suggests that features are not strongly separable, which in the affect model performance. And I have performed after that. I have performed the supervised machine learning. So first
Okay.
I selected the features and targets. So these are the features of and these concentrated energy loudness, and these are the features uh, and the target is popularity. We will see whether these features will affect on this popularity or not.
Okay.
Next, I have created the cross validation to check the model consistency. Then I have done the scaling process. Then there is a train and test split, which I have split into 80% training and 20% testing. After I have used the linear regression as a baseline model, because it is very simple as well as interpretable. Then I have used a
Okay.
random forest mm, because it handles the complex patterns better.
Yeah.
So we will see the model evaluation, how the model perform. So we can see that the R2 scores are very low as well as the MSC and the MAE score. So model explains that there are very little variance. So then after the visualization of the actual versus predicted, it is a scatter plot. It is used to compare. So the points are very scattered, meaning the model is not predicting correctly. So the final conclusion of this project shows that the predicting song popularity is very difficult using only audio features as song popularity has also other uh, mm, outside reasons.
Okay.
So this was all my
Okay. Okay.
work.
Great work, Pranav. Also, you have shared the calibration report. So, good work. All the 3 week projects, you are continuously presenting them week wise. So, great work at your end. Just make sure that for the upcoming weeks, also you maintain this consistency. Okay. So, all the best for the upcoming weeks. And now I am sharing my screen so that I will tell you guys that what you have to do in the calibration report, and those students who have not submitted it up to now, they have to share it with me on WhatsApp only. Okay, so let me just share my screen first of all. I hope my screen is visible to all of you. So basically, this is the project calibration report, which is created for all the domain, data analytics, full stack, and AI/ML. So if you belongs to data analytics domain, then you have to only fill these columns related to that, and just remove MERN stack development column from part from there, and as well as AI/ML from there. And what you have to basically answer in them is the question is given to you. Like suppose the problem statement, which problem statement you have opted for. In this, you have to let us know the reason that why you opted for that particular problem. That is one scenario. Then application features means suppose if you are creating a web page, which is for to-do application, right? So you have to mention their functionalities like in to-do you are performing create list, delete list, update list, and read list options. So like these, you have to answer the questions and you have to write your answer here in the student remark. Accordingly, just to enhance the space and do the formatting so that it will look good and you can incorporate your answers over there. One another thing is that few topics may be there which is not covered up to week 3. So if there is a question regarding that topic, you can skip that. Okay. And like suppose if we talk about API integration, if in full stack we have not covered API integration up to now, up to week 4, so you can just skip this question and try to answer the rest of other questions. Okay. So this is how you have to fill it for each domain. For every week you have to fill that. I hope now it is clear to you. I will share this template again in the group so that if someone haven't got it up to now, they will get it. So let me just share for it first of all. So I have shared it in the group. So now I hope it is clear to everyone. Okay, so that's it regarding this. Now let's continue with the presentation. So Aditi, have you now any doubt? If yes, then you can ask, otherwise no issues.
No, sir, it's fine.
Okay, okay. So Pranav has given the presentation, Aditi has given her presentation. Now, Lalit, are you there?
Yes, sir.
Okay, Lalit, so have you completed your project?
Yes, sir.
Okay, okay. So just share your screen and present it.
Okay.
Okay, okay, Pranshi, after Lalit, I will take your presentation.
My screen is visible. Hello.
Yes, Lalit, it is visible.
So, sir, I'm Lalit Bhardwaj. I'm from the domain AIML, and I have worked on the project titled Fashion Image Clustering. So, uh, in this
Okay.
project, I have uh, sorted the. Sorry. So, Very smart agent. Okay. So, sir, first I have downloaded the data set, and in the data set,
Yes.
so sir, in the data set, I have imported 70,000 photos previously, but
Okay.
the free memory provided by the Google Colab was not enough for managing them 70,000 images. So it was when I imported the 70,000 images, it started hanging. So I made imported only first 10,000 images,
Okay.
and
No issue.
the computer then understand the colors as numbers from 0 to 255 of the
Okay.
images, and to bring the numbers between. So I divided it and bring the numbers between 0 and 1. So it is called normalization. So it will simply help the computer to do the calculation and mathematical operations faster. So and I uses ready-made ready-made OS type thing, or brain, like a ready-made brain, which is VGG16, and it only accept sir, the problem is with the BGG, it that it only accept the color photos, which are named as three channels, and
Okay.
the minimum size of 32 by 32. So but the imported photos are in the are in black and white, and black and white in the one channel, and their size is 28 by 28. So I stretch the photo size a little bit and copy the black and white layer three times, so the model gets tricked into that thinking that they are colored photos. Like here I have repeated the photo size layer three times, so the model VGG16 thinking that it is a color photo. And here is the downloaded raw images data and resizing data. Then
Okay.
the smart scan comes. So here the scanning of the photos will be executed, and for their details. So instead of matching photos pixel by pixel, I have used a ready-made Google level model, which is this BG16, and it it uses a layer as include top is equal to false. This thing to because it will don't want it that this like in the image there are like fashion images of different clothings like shirt, t-shirt, pant, like things. So it
Okay.
will not make the this uh, brain BG16 to think of it as a shirt. Like for a image, for a image of a pant, it will not think as it as a pant. It will not normally think of it as a image. Like it will not
Okay.
detect the image for what the content it is showing. So I have just passed the photos through it, and it gives the deep summary of the shades, edges and textures in the photos. And finally, in the flatten this summary, it takes the big grid of the numbers and putting them into one long straight line. So the next formula can read it easily. Here it extracted the data details and the image features. Then third comes the PCA. It does the removing of the extra garbage like photos, like which images which are not useful or which have like not visibly correct visual visuals. So
Okay.
if we give all this heavy data to our gripping formula, it will getting confused. So I used the tool PCA, which works as a smart note taker. It takes the notes of the data and separates the matching data from unmatched data. So like it compressed the data into 50 most important points, which have in which it separates the useless background data, like not which bit data which is not useful for the for us, and it
Okay.
so it by removing the excess data, not like garbage data, it makes us more clear steps and makes the next functioning more faster.
Okay. Okay.
So uh, then we applied the k-means clustering. So it does the sorting the data into groups. So in the previous step, we have taken the 50 point summaries, and then it we provided it to k-means, and like it separated, and in the data set we have like 10 different types of items like shirt, shoes, bags, and or other clothing types
Okay.
wearable. And so the here the formula looks the data at and it automatically pushes the similar items together. So it gives the each photo a group number from 0 to 9. It like there are 10 different items, so it gives each item a different number and separate it into a group, separate
Okay.
group. But at this point, the computer doesn't know that what items are they. So it just knows all these items are in group 3, and it is confusing by looking like it very similar to each other. So
Yes.
by in the next step, we have calculated the result of score, that how it is working. So we have done a calculate using the cell hot score. Cell hot score. It is basically a test mark. If the score is closer to 1, it means the computer did a great job. But like it still makes a mistake, like from keeping the not the mistake. It separates the different items from different categories. Like it keeps the shoes and away from the shirts. And
Okay.
here comes this. So and at the last, this graph comes where it is a sellout score presented in the graph form.
Okay.
So these total dots combined together comes to like 10,000 different photos, fashion photos of um, different clothings. So every single dot on the screen represent one individual photo from the data set, and the 10 different colors match the 10 different groups, separate groups, and numbered from 0 to 9, and the algorithm created it automatically.
Okay.
And the axis is like -4 to 6, and there it represent the PCA components from 1 to 2, 1 and 2, sorry. So the data has a like a different 50 different points of information from the PCA step, which is like it was impossible to draw on a flat on this screen. It was not possible to draw it. So I have made in X and Y axis simply to represent it from the top two most important data points out of the 50 data points.
Okay.
So so by which it allows me to draw the 2D graph to see this overall result.
Good.
And so at the graph, we can visually check the algorithm's performance. Like some groups are clearly separated, like this blue one, and other many are differently separated because these are differently colored. So like the purple dots on the left side or the orange dot on the right side, and this shows the algorithm easily recognized those specific clothing items as unique, and it kept them separated from each other, but also kept them together like the same clothings in different groups, but togetherly.
Okay.
But in the middle of the graph, there are very clustering formed. So many colors like blue, red, and green are heavily mixed together here. So it shows that the algorithm found it very difficult to tell the difference between those specific items. Here our algorithm got again clustering, so it cannot found, and it got confused to tell the difference in some specific items. Like some clothings have it like some clothing have same colored clothings, then it there it get confused. So
Okay.
and so the sell out score comes to our 0.159. It comes to 0.159, which is the mathematical test score of our previous calculations. So it provides a clean separation without any mixing, and it also the score is closer to 1.0, 1.0, sorry. and but it is very lower than it. So the model helps successfully formed the groups, but there is a large amount of overlap and confusion between different type of clothing here happened. And sir, so overall, uh, the overall this all code provides the separation and helps me to find the to form the separation between different type of images and formed in different groups, and in like there are three or four, like there are 10 different type of images of different items, and it would help us to separate and formed them into similar groups, like two similar items in the same group or images.
Okay.
And that's all. Thank you, sir.
Okay. Okay. Good, Lalit. Uh, good explanation also. And that's good that you have completed the project on time. So great work. Now let's take the presentation for
Hello.
Priyanshi first.
Hello,
Yes,
sir.
Lalit. Yes.
Sir, currently I have not completed the calibration sheet, and can
Okay.
I send it till night, till
Okay.
8
Okay.
or
Yeah, you
9?
can send that. Okay. No problem.
Okay, sir. Thank you, sir.
Okay. So first Priyanshi will present and then Teja Reddy, I will take the presentation for you. Okay.
Good evening, sir.
Good
This is
evening.
my, I am from AI/ML domain, and this is my project on fashion image clustering using CNN for feature extraction and K means for clustering.
Okay.
Here we imported some libraries and method like model, max pooling for CNN, and to categorical to for one hot encoding in to our labels. And here we imported this. Fashion minutes train CSV from Kaggle, and we try to see how is there any none values here, and we can and we have seen there are none values. Then we clarify those. We just drop those columns, those rows, because we have a lot of amount of data, so we just drop them. And then uh, we did this unique to check how many levels we actually have, so we can see here is from 0 to 9, which is 10 levels we have totally in our data set. And then
Okay.
here and I want to see how our data set or images or this level contain which kind of images. So I just give this to this variable and the set index, because it doesn't have any index. So we need that index for iteration and loops. So we can see in our ninth level there is a collection of shoes or boot, you can say, or heels like this. And then we separated our labels and pixels, and then normalizes our pixel, which is in from 0 to 255 in zeros and ones. And then we reshape our pixel images, which is from 1 to 784 pixels into 2D form, so that we can pass our image to CNN. And then we change our label to one hot encoding. We did one hot encoding in our label, and then we made
Okay.
an input layer for our CNN. And then this is the first layer, and this is the second layer for our convolutional neural network. First we have applied 32 filters, and then we applied 64 filters with 3 grid. And then for each convolution filter we did max pooling for decreasing or reducing our dimensions. And then we applied our dense layer which just flatten these all to 180 128 dimension vector. This
Okay.
will be an 1D array, you can say. And then we just did our last input layer, which will map this feature layer to output, and we take it 10 because we have 10 clusters. We will make 10 cluster afterward, and we have 10 labels. So we did output for 10, and then we imported our model method, which works which will make our pipeline from input to output. And then we um, compile our model and give it a Adam optimizer for optimizing errors and improving weights, and by using this categorical cross entropy. This is best for clustering and classification type of data set. And this will calculate loss and accuracy, and then change our weight to perform best in all cases. Then we will fit our model to our train images and labels, and we give 5 epoch. So it will run 5 times, and give a batch size 128. So it will run each time 128 image will be processes. And then we can see at each epoch its accuracy is improving from 77 to 89. This accuracy will fluctuate if our data set will be given properly. Here my data set isn't fully loaded to this, so its accuracy is 89, but before it is 90 and 92. Then
Yes.
then we extracted our most important features from those features which have extracted here. Then we
Okay.
extracted those features, and then we give um, those feature to our k-means. We imported our k-means and made 10 cluster with fixed randomness, and we fit our k-means with features we have extracted above by CNN. And then we use PCA so that we can plot our so we can plot how our k-means clustering happens here, how those are. So we just we have 128 features, so we use PCA to reduce it to two-dimensional. I
Okay.
mean, we have 128 the numbers in row, which is impossible to actually plot to this. So we reduce it to two main principal component, and then we plot it. And here we can see those are you can see similar clusters, similar color clusters are there. There are a total of 10 colors and 10 cluster. Then we want to see how our k-means actually clusters those. So we loop through our 9 cluster, and then we can see how our model have clustered it. So you can see there is shoes and boot images cluster 2, cluster 0, and for 1 this these are women dresses. And for cluster 2 these are full, or I mean I think it's jacket and winter dress. And this cluster is for pants, and here it is purse
Okay.
and all. And last we have again check our CNN accuracy. Actually, we don't actually need to test our test data set on this, because while running our train and while learning, it already have check all the loss and accuracy at the time. But we still did to our test data set, and we get 89% of accuracy. Thank you.
Okay. Okay. Very well explained, Priyanshi. Good work at your end. And also you have shared your calibration report. So great. Keep going like this. Now,
Thank you, sir.
yeah. Now, Teja, are you ready with your presentation?
Yes, sir.
Okay, okay. So just share your screen and let us know what you have created and then start with the presentation. All the best.
Okay, sir.
Up to then, who else is remaining for the presentation? Mansi, only Mansi and Ameya Jose.
1 second, sir.
Okay, okay. So,
I'll be sharing the screen.
yeah, yeah.
So,
You can
sir,
share.
like due to like last week, I have my mid exam, so that I was unable to concentrate on that. So that I have completed only week two one. So
Oh,
tomorrow I can able to make out that also.
okay, okay. No problem. Then on Friday, give the week three presentation or whatever the project is remaining. For that, you will give the presentation on Friday. Okay.
Okay.
Yeah. So after this, Mansi, you have to present, and then Ameya, you have to present. Okay.
Uh, okay, sir. My project is on climate change data analysis. So
Okay.
this is week two project. So
Okay.
basically, I have used some data, one a data set from Kaggle only.
Okay.
So the pipeline starts with the data inputting and then goes with the data cleaning. And I have performed exploratory data analysis, then correlation analysis, then moving ahead with the visualizations about how the plottings and all. Then after that, how the forecasting happens. Then pivot tables. Then whatever the insights that can able to draw, like conclude from the overall analysis that I have done. Then see, I have used pandas for data manipulation and NumPy for calculating extreme calculations in standard deviation or any kind of central tendency measures. Then Matplotlib for the plotting the different types of visualizations in Python. And Seaborn is for the extreme level of visualizations, like when you go for any correlation matrix and all, we use this. And moving ahead, have imported the data set here. Then this data set contains thousand rows and 9 columns. And the
Okay.
fields of this data set are the date of the like whatever the data that we collected on which date, and the location and the country, the temperature, CO2 emissions, and the sea level risings, and the humidity. All these values will be recorded in as the attributes of the data set. Then moving ahead with the data cleaning process, this actually means like how to prepare the raw data into a meaningful insight. So here we will be having different operations like finding the missing values, how to whatever the duplicate rows that we can able to find. All these we can do in the second stage. Then here whatever the calculates here you can able to see all this statistical summaries like mean, standard deviation, min, max, all this climate variables we can able to record here. This comes under descriptive statistics. Then
Okay.
moving ahead, we'll be going with exploratory data analysis. I'll show here. This exploratory data analysis, all those calculations will come under. Then this EDA will show prints the output like how the average temperature, CO2, all this, how it behaving in the last 10 years, and whatever the top average counts of the CO2 emissions. And then moving ahead with the correlation analysis. Here we are using linear correlation. So basically, whatever we'll be having one dependent variable and one independent variable.
So we'll be having climatic variables. The independent variable is no, the dependent variable is uh, carbon dioxide levels, and the independent variable is temperature. Then based on this, visualizations also being drawn from here, and in this output, I can able to show that also. In the forecasting, when the sixth stage, we'll be having how the forecasting happens. One second. All this shows the forecasting visualizations. Then moving ahead, we'll be having pivot tables. Those pivot tables are actually like for the main purpose serves for the summarizing and aggregating the different multiple dimensions. Let's say we'll be having on the particular time period how the average values, like whatever the carbon dioxide emissions that you're comparing the different countries on which periods. Like here we'll be having from 2000 to 2010,
Okay.
like for the last 10 years. Then moving ahead, these are the values that we are able to printing. Like these are the significant measures that we can able to draw from the data set. Then all these results. Here you can able to see these are the this shows whatever the fields of the data set: country, location, CO2 emission, sea level rise, precipitation, humidity, wind speed, all this data cleaning process. And mm, here all the visualization shows those. Like this red color shows the temperature, and this shows the how the carbon dioxide levels are increasing. And whatever this line shows how the trend goes on. This dotted line shows that.
Okay.
Same it follows, and this bar graph is basically to find the wind speed distribution on which they on this which particular year, like from 2000 to 2002. For every 2 years, I have took the scale, and this correlation matrix, correlation analysis shows how the relationship. It shows that there is a very weak correlation between the temperature and CO2. You can able to see all this. Those are in very light color. That means the correlation is in negative, and that too it is a very weak correlation. And this
Okay.
is a box plot. This box plot shows how on each variables, like whatever the climate variables that are available in the data set, that shows like for every uh, climatic variables, how it is behaving with the temperature and humidity, everything. You can able to see this also. This
Okay.
visualization shows the final pivot tables. Okay, sir. If you have
Okay.
any queries on that, you can ask.
Okay. Okay. So first of all, very well explained, Seja. And also the project was good. So that's great that you have completed within your mid-sems exam. Good work. Now, just one thing is that there is project calibration report also. Okay,
Okay,
so that you have to submit, but take your time, no hurry. And whenever
okay,
you complete your week 3 project, you can submit that and present
okay,
that. Okay, yeah,
okay.
great work.
Thank you, sir.
So now, Mansi, are you ready with your presentation?
Yes, sir. I'll share
Okay,
my screen.
yeah, all the best.
So, can you see my screen?
Yes, it is visible. You can start
Okay.
with.
Okay. Hello everyone. I'm Nancy Editor. My domain is AI/ML. My project name is age versus spending cluster analysis. The problem statement is the goal of this project is to identify distinct groups with similar customer purchasing behavior using k-means based on age and spending score. So these are the libraries I've imported. sklearn is used for importing the k-means model and standard scalar as well as silhouette score. Here I've loaded the dataset. I've mounted the drive and then loaded the dataset. I've done df.copy and saved it as df clean. Further analysis will be done on DF clean. For first
Okay.
view, I've used head to give the first 5 rows. DF clean.shape is used to get number of rows and number of columns. There are 200 rows and 7 columns. DF clean.d types gives the data types of each of the columns. DF clean.info gives the non-null count of each columns and its respective data types. So I've checked for missing values by using dfclean.isnull.sum. Here you can see that there are no missing values throughout the data set. So there's no more further cleaning to be done for missing values. dfclean.duplicated.sum is used to check for duplicate values, and there are no duplicate values. For what do you know about your data set, I've written about the data set. There are 200 rows, 7 columns. Customer ID, age, annual income, and spending score are the numerical data, and gender, education, and marital status are the categorical data. Like the analysis we've done here, we can say that there are no missing values and duplicate values. But if you see the attribute names, there might be remaining spaces before and after the name, as well as between two words. And brackets are also not really considered as consistent data types. So we'll be changing all of that in the pre-processing or cleaning step. So for dataset columns, I've used dfclean.columns or toolist to get a list of all the columns in the dataset.
Okay.
dfclean.describe gives the summary statistics of each numerical column. Like I've mentioned before, these are the numerical columns, and we get the statistics of each of the columns. Customer ID is a unique identifier for each customer. Gender gives the gender of the customer. Age gives the age. Education is the customer's highest education qualification. Marital status gives the marital status of the customer. Annual income is the annual income in $1,000 for each customer. Spending score is just the score assigned based on the customer's spending behavior. dfclean.nunique gives the number of unique values in each column. For data cleaning, like I mentioned before, we need to remove the extra space before and after the name, as well as between two words of the column name. Dot strip removes the remaining spaces before and after the word. Here, dot
Okay.
replace every in the attribute, wherever there's space, it's replaced by an underscore because it's a valid, it makes sure that the data type is consistent. So if you're making changes to it later, it doesn't cause an error in the data set. So the bracket is also replaced. And then I've done encoding for categorical variables. I've used label encoding for gender. Here, gender, it only has M and F. So for such binary data, it is better to use label encoding because using a single mapping, we can do the encoding. So M is shown as 1 and F is shown as 0. We can see the results here. And then I've used one hot encoding for marital status and education. So what happens in marital status, we have married, single, and unknown. We have married, single, and unknown. So if the customer is married, it shows 1, or else everything else is 0. Similarly, if the customer is single, it shows 1 and every other data type is shown 0. Similarly, I've done it for education levels as well. So yeah, here you can see the difference between this and after encoding, whatever the data set has become. And then I've done feature scaling. That is, I've standardized every numerical column in the data set. So no certain attribute is dominating the data set. This is an important step for further analysis. So yeah, I've used standard scalar, fit transform on X, which is the numerical features. And then I've created a data frame on that. So I'll be using X scaled for K selection, elbow method, as well as silhouette score. So for K selection, in elbow
Yeah.
method, elbow method basically, it helps us to identify the optimal number of clusters. So it gives the compactness of each cluster. Here, I've done a for loop where it's going to execute 10 times. So a random centroid is taken, and then after each loop, a different centroid is taken, and the WCSS is calculated for each cluster. And that is appended in WCSS, the list here. And then for plotting, I've plotted WCSS for the y-axis and number of clusters on the x-axis. here we can see that in k is equal to 6, the decrease in WCSS reduces. So the graph, you can see that it reduces a lot here, and then it starts stabilizing after k is equal to 6. So this shows that 6 is the optimal number of clusters which should be used in the k-means clustering. So that's the interpretation. Silhouette score, it basically gives the closeness of the data points in the same cluster, as well as how far each cluster is from each other. And here, like before, I've done a for loop where for each number of clusters, it's going to give the silhouette score. So n clusters is equal to k. So from 2 to 11 is going to check because k is equal to 1 cannot have a silhouette score. So silhouette score basically gives the value from -1 to 1. And whichever value is closer to 1, that is the um, uh, k value which has the best clustering. So
Okay.
here we can see that in k is equal to 6, 0.42 is closest to 1. So this is the optimal number of clusters. As elbow method also gave k is equal to 6 as the optimal number of clusters, we'll take 6 as the number of clusters to be chosen. So for model building, I've used k-means, n clusters is equal to 6. That is, we're using 6 clusters. Random states, just make sure that every single time we're executing, it gives the same cluster. There's no randomization is the same thing. And n in it, that is just, it's repeating 10 times. So yeah. Here I've done a visualization to see each of the clusters. We can see 1, 2, 3, 4, 5, 6 clusters and how they've been made throughout the data set. This is age versus spending. So spending score is the major factor for clustering, and then it's followed by age. And clustering interpretation is done using group by. Here for each of the clusters which we've made here, we'll see the mean of age and spending score in each of the clusters. So using this, we can analyze this and make interpretations based off this. So
Okay.
here we can see that maximum spending score is 82 and 77 by the age groups 32 and 25. So the younger age groups, these two, do have the maximum spending scores. They are followed by 49 and 48 spending score by the age group 56 and 26. They are the mid-level spenders, which don't fall under the younger category as well as the older category. There is a wide age group. And then it's followed by 19 and 16 spending score by the age groups 45 and 41. So the mid-age groups have the lowest spending score. So through this interpretation, businesses and other e-commerce companies can use this interpretation to make better marketing strategies to get better customers, etc. So that's it about my project. Thank you.
Okay, okay. Great work, Mansi. Good. So now I think only last one, Ameya, is left for her presentation. So we can proceed with her. Good work, Mansi. Keep continue. Okay, so Ameya, are you
Can you see the screen, sir?
yes, your screen is visible. You can start with the presentation.
Okay, sir. So my project is customer segmentation and printing. It's audible, right?
Yes, you are audible.
Okay. So my project is customer segmentation and prediction using machine learning. So the
Okay.
goal of this project is to analyze the customer data and predict their spending behavior using supervised machine learning techniques. Okay, so in retail businesses and all, customers behave differently based on their income and preferences. So the objective is to analyze the customer behavior and to understand patterns using data and to predict their spending scores using machine learning. In this project is basically belonging to the supervised learning category, specifically a regression problem, because we are predicting a continuous value that is a spending score. So in this, I have used MAL customer dataset, which contains customer ID, age, gender, annual income, and spending scores. This spending score represent how actively a customer spends in the store.
Okay.
Then I loaded the dataset using pandas and displayed the first few rows to understand the structure of the data. Then uh, uh, I used functions like info and describe to understand the data type, number of entries, statistical properties like mean and standard deviation and all. Uh, then I checked for missing values using eSnull. There were no missing values, so the data set was already clean and ready for analysis. Then I used histograms to understand the distribution of age, income, then also spending score.
Okay. Okay.
This helped me understand how the customers are distributed across different ranges. Then, in by variant analysis, I plotted the annual income and the spending score. So, in this graph, it shows the customers from natural patterns and groups based on their behavior. Then, I used a heat map to understand the relationships between variables. It showed that the income and spendings are not strongly correlated. What it means is that customer behavior varies significantly. Then about the feature selection part, I have selected age, annual income as the input features and the spending score as the target variable. And here feature scaling is done for the normalization purpose. Then I split the data set into training and testing sets using 8:20 ratio, where training data is used to train the model and testing data is used to evaluate the performance. And then I use linear regression here, which is a supervised learning algorithm used for predicting various values. It finds a relationship between input features and output.
Okay. Good.
Mhm. I train the model using training data. The model learns the relationship between this age, income, and spending scores and all. Then I use the training model to predict the spending score on the data, test data. Then I evaluated the model using mean squared error. This metrics measures how close the predicted values are to the actual value. Lower error means that it has having better performance. Then the model was able to predict the spending score based on the customer features. So this shows that customer behavior can be estimated using machine learning.
Okay.
In this project, uh, if this project can help businesses like to identify their high value customers, to predict spending behavior, and to improve their market strategies and personalize their offers. This has advantages and limitations also. So first, I will talk about the advantages, that it is very easy to implement and it is useful for business decisions, and it works well for structured data. The limitations are linear regressions assumes a linear relationship and it may not capture complex patterns, and it only uses limiter features. So for future improvements, we can use features like gender and all, and we can also apply advanced models like random forest, and also real-time data can also be used. So in
Okay.
conclusion, this project demonstrates how supervised learning can be used to predict customer behavior and support better business decisions. So that's all that is.
Okay. Okay. Well done, Ameya. Good project and also very well explained. So all the students who have given the presentation today, well done guys, you have done a great job and I can see the fluency as well as growth. So keep continuing like this and you all are doing a great job. So that is appreciated. Well, so thank you. Now I think that no one is left for the presentation. So we can just wrap up this session and we'll connect on Friday so that other student can also perform and you can watch them performing. Okay. So thank you so much. Now you can leave. Uh, or just remember to share that project calibration report with me. Okay. Okay.
Okay,
Have
sir.
a nice
Thank you.
day. Okay. Bye. Thank you.